Okay. Okay, perfect. So again, my name is Alejandro Rodriguez. I'm professor at Computer Science School as well as the Center of Biomedical Technology. And this first seminar, as part of the data science seminars of AT Digital Data Science and other masters, will be about the topic of disease understanding. Okay, what we are going to show, both me and my colleague Lucia, that will also be part of the instructor of this seminar, it's about the problem of dealing with complex and structured data or structured big data in the biomedical domain. Well, I would like to try to make the seminar as, let's say, not boring, not much boring as possible. This is something that is difficult when you are giving a seminar at on Fridays at 3 o'clock in the afternoon, just after lunch, most of us probably. So that means that I would like to try to ask you to participate. If you have any doubt, please ask. You can interrupt me. This is something that when we are in a physical classroom in a normal lecture, it's more, it's much more easy to do. I know that this format of online lessons probably will make the things a little bit more difficult, but please, again, if you have any doubt or any comment, you can interrupt me, and indeed I will ask some questions to you that I would like to have your participations. Okay, so the seminar, as Javier said, is expected a length of 3 hours. This is the expected length that we normally have when we are in a physical lecture. My experience is that normally this can be a little bit reduced, but don't worry too much. The content at the end is the one expected for the 3 hours, and as well as the assignments with that will cover more or less the time frame that Javier showed. So, well, all the material will be at this URL. Okay, so I will give you later the link through the chat. You have this short URL. Well, there are some material already available there. Once I finish once I finish the seminar, I will upload the slides also, that they are not there yet, as well as the video. That the video probably I will upload it to the YouTube channel that we have. In database, let's say, area, we have a YouTube channel where we will upload all our material about all subjects. So I will upload there the link to the video. Okay. So what is the agenda that we are going to see today? So these are the topics. Okay, what is medical informatics, diagnosis problem, medical knowledge, representation and data sources, and as well as acquisition. And we're going to talk about diagnosis, knowledge acquisition. And in this part, between the points 6 and 7, Lucia will talk about a specific topic that is of wide interest, and it's part of the seminar. And I said that it's of wide interest because she will especially focus or cover one part that it's talking about the COVID-19 and some strategies that we are doing right now in the laboratory that I led on this matter with a project that is called DisNet, and I will explain at the end of the presentation. So I would like to start with this question. Every time that you see in the slide this, figure or image, it's like an open question for you. So I would like to ask you if any of you wants or is willing to answer this question. What is medical informatics, or what do you consider that it's medical informatics? Who wants to answer?
I think that medical informatics is all the complete group of technologies used in the medical field for this approach for medical applications.
Okay, can you give me that's a good question. That's a good explanation. Can you give me an example can you imagine an example of what can be a medical informatics, I don't know, application or approach?
Yeah, for example, the the tools used for do exams like cardiogramas
Okay, okay, okay.
and studies. When in this file use data mining for research about one specific disease, I think that is also informative in medical file.
Okay. Okay. Yeah, that are two examples that can somehow approach to this medical informatics concept. I show you this let's say tag cloud, okay, of what this is of health informatics. There is a, let's say, not very clear line about the difference when we are talking about medical informatics, health informatics. Let's say that some people talk about health informatics when we are dealing more with public health issues from a computational or an informatics perspective. But the idea is that, as you said, Alison, the idea is applying, let's say, these ICT or information and communication technologies to the medical domain. Okay, this can be done, or this can be applied to several things, and you can think, okay, but I mean, nowadays we are using computers for everything, so everything can be somehow considered medical informatics. Well, that's the thing. Right now, this is a reality. We use computers for everything, but this is more when we are approaching the use of the computers to solve or to help to solve medical related problems. And this can be from things like, can be the electronic health records. Okay, you remember, I don't know how young you are, but the thing is that if you are old enough to know this that I'm going to explain, you will remember that when you go to the physician, when you were a child, probably the physician were taking notes about what was happening to you, maybe in a piece of paper. Okay, that this is the electronic records that were not, of course, they were not, sorry, electronic records, not the health records, that of course they were not electronic, okay, because all these records were taking a piece of paper, handwritten. Nowadays, if you go to the physician is taking these notes in a computer. Okay, what basically is your personal history, your medical history, but it's electronic, so it's electronic health records. This is an application that can consider of wide interest for the medical informatics area, okay, because it's basically applying ICT to improve some of the medical processes. Okay, in this case is just the capture the capture of the information from a patient, but this is really important because imagine the difference nowadays of trying to search something in the history of a patient in comparison with trying to do this search on a piece of paper. Okay, this is something that has improved a lot the storage and the capabilities of search information about a patient in his or her history. Okay, but this is not the only thing. As Alison said, there are many other things that are related with the extraction or acquisition of knowledge, like can be, for example, an echocardiography, or can be an electroencephalography or something like that. Of course, use on some side, let's say, some electronic devices to capture this information, plus some ICT technologies to interpret it, visualize it, or even analyze it. Okay, or for example, the approaches that Alison also mentioned about applying data mining or artificial intelligence based things to this concept. Sorry, I have my cats over here trying to, I don't know if they are interested in the class also. So that's one of the disadvantages of online classes, especially if you are from your home. So there are many things, okay? For example, one of the things that we are going to cover, and Lucia will cover, it's about the process of trying to find new uses for existing drugs that it's called drug repurposing or drug repositioning using computational approaches. Okay, this is also part of the medical or biomedical informatics. So there are many things, okay, that are part of this. One of the things that I would like to start covering as introduction to this seminar is and will be related with this, this concept of medical informatics is the diagnosis problem. So can any of you explain me how is performed the diagnosis in medicine? Or I mean, do you have any idea? Probably if you have seen the TV show House, you can give me an answer.
Could I?
Yeah, sure. Sorry.
Yeah. There are a set of approaches that are taught from the university and maybe change, all through the years. They have a guided structure what should be performed from the very beginning. That like exploration, several like tests are performed, and after based on this thing, the diagnosis is conducted. Also, there could be some kind of outliers in the diagnosis. That's why there are kind of approaches also where there is a committee of people gathering and deciding what to do if this doesn't follow the template.
Okay, well, this is like a broad explanation, or probably a much broader than the one that I was looking for, but it's okay. I was more focused on the idea that when, for example, when you go to the physician, and remember the idea that I was explaining before. When you go to the physician, the first question that the physician asks you is, okay, what is, sorry, let me, 1 second. It's asking, it's, 1 second, sorry. Sorry, because my cat was, meow, 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 and it was driving me crazy. So again, when you go to the physician, the first question that probably he or she will ask you is, okay, what is happening to you? And you will start explaining, okay, what are your feelings, what are your symptoms, what are, I mean, let's say your general status that allows him to have a first idea of what is happening to you. Nowadays, for example, this is something that we, well, sadly, we are experiencing about, let's say, I don't know how to say it, but with the COVID-19, this is something that it's making the diagnosis like more in focus. I mean, a lot of people is talking about that, and it's like when you are starting feeling bad, and well, now if you have fever, you have cough, maybe a couple of symptoms more, it is, I mean, it is likely that the main diagnosis that they will consider will be COVID-19, okay? Indeed, one of the things that is happening, at least in Spain, I don't know in other countries, is that when you go to the physician with some symptoms like that, they will do the COVID-19 test, and if it's negative, it's like, okay, that doesn't matter what other thing do you have, okay? It's like, unless you are really, really bad, okay? It's a reality. And this is part of how the diagnosis process is made, okay? So the idea is that the diagnosis at the end is using this, let's say, in a first, let's say, stage, more or less simple model that it's basically you have the disease that has a relation with a finding or with the results of the diagnostic test, okay? Which makes basically in a let's say, informatics point of view, that the diagnosis of a disease is based in what is called non-monotonic logic, okay? That means that an increase in the input findings decrease the resulting outputs, okay? Because as much symptoms, let's say, or as much information do you have, the number of possible options that are your disease are reduced, okay? So the diagnosis in this context, of course, I'm not talking about a more extensive, let's say, a procedure as you were describing, that of course I completely agree, but let's say in a reduced or in a simple perspective, it's based on these two elements, findings that include symptoms and signs, Well, the difference between both is basically that the symptom is, let's say, it's a more subjective perspective of your condition. A typical example is when you think, I think I have fever, or you go to the physician, I have fever and I have 40 degrees. Okay, 40 degrees is not considered fever, it's considered hyperpyrexia. While, for example, between, I don't know, 38 and 39.5, it's fever, and below 38, it's, I don't remember right now, but it's yeah, low fever. Okay, in Spanish has another name. Okay, and this is, let's say, like the conversion between both. Or I have some you know, something in my skin that it's you know, I scratch all the time. So once the physician see it, he can or she can tell you if it's an erythema or if it's a specific lesion, skin lesion. Okay, so that's the difference basically between the symptoms and the sign. From a subjective perspective, that it's normally made by the patient, and let's say more objective valoration that is normally made by the physician. And well, as I said, the diagnostic test. So, well, that's the difference, okay, of the symptom and sign that I already explained. So we will move forward. So the diagnosis, it's a difficult problem, basically, because there are several things that we need to consider. The first one is that the findings that we have as part of the let's say diagnosis problem itself are very unspecific. Okay, we have same symptoms for different diseases. There are only a few diseases that contain what is called the pathognomic findings, like the Koplik spots in, sorry, this is double M, in measles, the Askov bodies that are some nodules in the heart, in rheumatic fever, etc. So these are these are not very common. Okay, these pathognomic findings that allows to go directly and to know that this is a very specific disease. The reality is that normally we have several options. The second one is the comorbidity problem, that it's the presence of one or more additional disorders or disease that can co-occur with the primary one. Okay, this is very usual in elderly people that, you know, they are getting older, and it's more probable that they will have some diseases occurring at the same time. Another thing is the clinical manifestations of a disease, that they are not a binary problem, okay, a binary value. The prevalence of the findings is a factor to take into account, but the prevalence of the findings in a disease are really dependent on the population where this disease has been studied. Okay, so for example, it is not probably this. Well, it's depending on the population for several reasons. Okay, it is not the same to study influenza. Influenza is not a good example. I'm trying. I remember that Lucia told me the other day another disease, but I don't remember exactly which one it was. But there are some diseases that for some reasons produce, let's say, different manifestations or different prevalence of manifestations, because there are some environmental or genetic factors that are, I think that Lucia maybe answered me in the chat. Cholera, okay. The cholera, okay. They are different populations to be studied, probably produce different results in terms of the manifestations. On one hand, can produce different symptoms, or on another hand, can produce different prevalence of these symptoms, okay, or these findings. And this can be for several reasons. One can be, for example, the environmental factors. It is not the same. Imagine the temperature, living habits, or whatever in United States as the ones that for example, the Japanese population have. So these can produce several differences. On the other hand, there is another element to take into account. This is the genetics, okay, or the biological aspects. So the population from a genetical perspective in Japan also, it will have difference with the general population, general Caucasic population, for example, okay? So this is something that needs to be taken into account. Oops, sorry. So, okay. On the other hand, the findings, the symptoms or signs, are the manifestation of an external agent or a mutation in a specific host, okay? And these things depends, as I said, on this specific genetic or biological information or environmental factors. I will tell you now a real case, okay, of how, for example, the computer systems can really help to the health sector, and more specifically to the diagnosis approach. I will start saying that I have started working on the medical area since I finished my bachelor. I did my end of bachelor project on this topic. Indeed, what I did was a diagnosis system, okay, using some technologies, semantic web technologies, and rule-based systems. This was indeed part of my PhD thesis at the end, that I extend much more from the, of course, of the bachelor project, but it was part of my research of my PhD. So let's say that these diagnosis systems, I would say that I know them very well. I know how effective can be, and I know exactly how can they help in comparison with the capabilities or the capacities of a person. Okay, and I will explain you this specific case that it's, as I said, a true story. That it's something that happened to me in Thailand. Okay, so the thing, I was in Thailand in 2014. I was with my girlfriend. We were doing a trip around the country. Okay. I did three things that if I now think on, I think on them, probably I will not do again. I think that if I was now in Thailand, probably I will skip these activities. Well, they were not in this order. Indeed, the first thing that I did, well, I mean, now you cannot see me in person, but if you see me in person, I have a lot of tattoos in all my body, my hands, my arms, most of my body. Okay. So the thing is that I really like the tattoos. So one thing that I did in Thailand was, as you can see in the picture in the left bottom side, is make a tattoo, okay, with the traditional style, with bamboo. I don't remember the name exactly. So this is the first thing that I did, okay, in a study with all the expected sanitary conditions, but well, I mean, probably I will say that it's not Europe, okay? With this, I think that we all understand what that means, but the reality is that I think that my problem was not because of the tattoo. The second thing that I did is that, well, I went, I remember that I went with my girlfriend, you know, we were doing a trip, and we had, as part of the thing that we hired, we had rafting in a river. Okay, and what happens here is that while we were doing rafting, you know, through the river, we found a part of the river that was, you know, with more rocks, and the water was stronger. And the problem was that I don't know how to say in English the name of this boat where we were, but let's say boat. Okay, the boat. How to say in English?
Rafting.
Sorry.
Rafting.
Yeah, rafting is the activity, no, but I want to say that se dio la vuelta, turn over, okay, or something like that. And the thing is that I fall into the river, okay, and I fall into the river, but the problem that happened is that if the river is, you know, going down, I don't know if you can see my camera at this moment. Can you see my face, the things that I'm doing with my...
Yes.
Okay, so when I was, you know, the river is like that. So we were in the boat flip over, I think is a good expression. And the thing is that if the river and the boat is on this direction, I was here, okay? So I was not able to catch the boat. So the river, I continue with the river like, I don't know, 200, 300 meters. The problem there is that the code, the live word code that I had was not, like I will say, very safe indeed. I think that it was even worse than not having anything. I was about to drown several times. I mean, to be honest, I thought that I was going to die in this river, okay? Because I mean, I was drowning. I was not able to go to exit the river. When I had the opportunity of stopping somehow, what happened is that I tried to, to put my feet in the ground. I remember that with the rocks of the, of the part of the river, I had several injuries in my feet because of the rocks and all the things that were in the soil of the of the of the river. One second. So the problem is that well, I was finally I was able to catch a tree that was in the middle of the river, and when I catch this tree, I was able to not continue going with the river, which helped me to be, let's say, rescued finally by the boat where I was in. Okay, well, finally we arrived to one part of the river, and I get out. And the third thing that this is the second one that I did, that, as you can imagine, was really dangerous. Well, I was about to drown, so I swallowed a lot of water from the river, so it was really really difficult situation. And the third one that I did, because, well, at the end, okay, there was some injuries in my feet, but nothing serious, okay. So we continued the trip. I remember that in Khao San Road, that is like when all the people goes in Thailand, all the tourists. What I did is I ate a scorpion. Okay, you can see there the picture. So the result was this. Okay, I remember that I come back from Thailand, and around 2 days after coming back from Thailand, I start to feel really bad, really bad. I went to the physician, and the physician told me, no problem. I mean, this is just something, a virus or something like that. So he just gave me paracetamol and ibuprofen. Okay, ibuprofen. So the thing is that it was funny. He was trying to solve everything with paracetamol. Indeed, most of the physicians. There is another story that I was now in the hospital also with COVID-19, like 3 weeks ago or 4 weeks ago. It was also really bad. But the first thing that they give you, it's also paracetamol. Luckily for the COVID-19, they give me another things. But the thing is that when I was in the physician, he told me, no, it's okay. It's just something medical. Don't worry. I was really bad after 3 or 4 days. So my girlfriend took me to the emergencies. Well, when I entered into emergencies, I at this moment I had jaundice. That it's when you start having your eyes a bit yellow, okay, and it's because the liver is failing, okay. So, well, finally I get admitted into the hospital, and I was there like think that 5 days, okay. The thing is that they did me a lot of tests, and all the tests were negative, and they didn't know what was happening to me. So the solution was, okay, we don't know. What we are going to give you, it's an antibiotic, okay, high range antibiotic that kills all, let's say, the type of bacteria, gram positive, gram negative. And this was the solution at the end. Was the solution because what I had was a bacteria, okay, that indeed they give me cephalosporin, that was the specific antibiotic that needs to be given to this specific bacteria. But they didn't know what happened to me. And they didn't know, indeed, they didn't even suspect what was the most probable case, because they are starting, I mean, they know the symptoms, they know the findings on the laboratory test, and they start to think, okay, let's think what can be the most probable option. But the most probable option is not the same here in Spain as can be in Thailand, or can be in Vietnam, or can be in United States, or can be in any other part of the world. There are really clear differences because the prevalence of the diseases is completely different in different parts of the world. They know, they knew that I was in Thailand. They knew that I fell into a river. They knew that I did a tattoo. They knew that I ate an scorpion. But and they start searching for options, exotic options for Spain. But none of the serologies give a positive result. What I had finally was called leptospirosis. That it's a disease caused by a bacteria. It's called Leptospira. Basically, the Leptospira is a bacteria that it's normally quite well. I know that I had leptospirosis because when I went to the hospital, I don't know, like 1 month after recover, because they had to make me some tests in the liver because I was with the liver really, really bad, and they need to check that was everything okay. And they told me, hey, do you remember that we did you a lot of tests? One of them finally gave a positive result, and was this leptospirosis, okay, the Leptospira. But they knew the result, like 2 weeks after I get out of the hospital. Indeed, they give me the discharge of the hospital with the diagnosis of fever of the traveler. Okay, they didn't know fever of the traveler is like, we don't know what is happening to you, so give this name of because you had a lot of fever. It was one of my main symptoms along many others, but yeah, it was true that I had a lot of fever. So was the diagnosis. But finally, as I told you, one of the results gives this Leptospira. And as I was telling you, the Leptospira is a bacteria that is quite present in the urine of the rats. Okay, so the most probable option is that when I fall into the river, when I was in Thailand, was in this part of the year with the rains, the monsoon, okay, that there are a lot of rains, so all the rivers probably are, with a lot of things that they are arrastrando. I don't know how to say in English, where they are moving from the mountains, and all the soil from the mountains and all the things. So probably the river contains this bacteria in the water, and was the most probable case of my disease. Because the reality is my girlfriend also fall down, but she was not so much time in the river. She was able to take the boat, and she didn't had this such bad experience. So this happens to me. And why I said that this diagnosis might be able to, let's say, why I said that a diagnosis system or applying medical informatics to this problem can help. Because the diagnosis problem is a problem that can be improved from a computational perspective, okay? Most of the diagnosis systems are based on approaches like rule-based, probabilistic, or machine learning. The thing is that, and this is something that I have experienced, because as I said, I did my bachelor on this, my bachelor end of bachelor project on this. If you take into account some extra information, like for example, the countries that has been visited by the patient, you can recalculate easily what are the most probable options based on the specific countries that has been visited. You can recalculate also considering, for example, the prevalence of the symptoms, okay, that are part of the different diseases. And all these things are things that can be, of course, can be done by the physicians also, but take into account the number of diseases that exist, and the number of combinations, the number of the huge number of data that is attached to the disease. So this is something that cannot be done from, let's say, a manual perspective, but a computer can help on that. So I think that in this context, the ICT can help to the diagnosis problem, okay? So the concept of the diagnosis, it's a computational approach that needs to deal with two basic elements, okay? On one hand, we need the knowledge basis with the clinical manifestation and the diagnostic test of a disease in order to make the relationships between those diseases, okay, and a way to represent this information that are the concepts and the relation among them, as well as as well as any other information that can be attached to this, like for example, the prevalence of the systems. So the next topic that I would like to cover is knowledge representation. And this is again an open question for you. How can we represent medical knowledge? How can we represent medical knowledge? Can you give me an example or an idea of how do you consider that we can represent medical knowledge? This is for you.
Like in a table, maybe with a one entry per user each day or something like that.
Okay, in a table, but in this case, we are, let's say, more focused on representing the information about diseases, okay? So, for example, can be in a table where we have the disease and we have the different symptoms in different columns. That can be an option, no? I think that you were thinking of something like that.
Yeah, something along that.
Okay, that's an option. Any other option?
We could make graphs of showing people how for example, how the COVID-19 transformed. Could be like something different in half a year.
Okay, so
trend.
a more graph-based structure. Okay, so that's the idea.
Sure.
Okay. Okay. Any other? Okay. Well, sorry. The thing is that this is a complex problem. Okay. Before going to the solution, or not the solution, there is no single solution. Okay. Indeed, both your answers are fine. Okay. There is one for me that I like more, and indeed is the one that I will explain a little bit more. There is a reason for that, and it's basically the representation capacities of the one that you mentioned. Okay, but the thing is that it's a really complex problem because on one hand we have several kinds of concepts to represent. On the other hand, those concepts can be simple or complex, that can be related among them. The concepts can have units, the concepts can be negated, time is also involved, so there are many things. Okay, so I would like to propose you an exercise. Okay, this exercise, I will give you 5 minutes just to think, okay? You don't need indeed to do nothing specifically, okay? This is just to think, but I would like to show you a possible solution to this exercise, okay? So, how to represent the following knowledge, okay? Indeed, what I'm showing you, it's more or less the problem of the leptospirosis that happened to me, okay? So this is a presentation. I give a clue. This is a representation about how to create a diagnosis system for the leptospirosis. Okay, so I give you this information. Can you think on how to represent this information and what are the main elements that we are considered given this statement? Okay, so give you 5 minutes, okay, and in 5 minutes I will show you my solution. Okay, it's just to make to make the things more dynamic. Okay, even taking into account that we are not going to see the solution of all of you, because in class it's easier to, you show me some solutions and something like that, but here in online it's a bit difficult. But also to make a small break and you can think and relax a bit, think on this, okay, and I come back in 5 minutes more or less, and I give you a solution, but I will ask you before what entities have you identified, what information, how do you think that can be represented, okay? And you can give me your potential solutions. Okay, 5 minutes. I will come back in 5 minutes. Okay, I'm here again. So, any of you can give me any possible entities that you think that needs to be modeled as part of the knowledge representation of this statement? What are the main entities that you have identified? Remember that we want to model like a diagnosis system for the leptospirosis, okay? So based on this statement, what are the entities, okay, general entities that have you have identified?
Symptoms.
Symptoms,
The incubation period
okay,
could be relevant.
okay, yes. What else?
Treatment
Uh,
duration.
Treatments,
Specifically, the paralysis could be something to modelize in order to discharge this bacteria.
okay, okay, yeah, that's part of the symptoms, but has
Yeah.
some specific meaning. But okay.
Yes, yes.
What else?
Yeah. And then I guess we could also use some rules in order to, like a rule-based system to determine in which phase the person is at.
Okay, good point. But take into account that now we are, let's say, just
Okay, yeah.
defining a model, okay, to capture the information. We are not yet going to identify this, but it's important. The important thing there, I think, is that one of the entities is that there are different phases. So each phase is a potential entity in the statement, okay?
Then I guess that some symptoms are like continuous, that it's not either 0 or 1.
Mm-hmm.
So we might need to
The
distinguish between.
percentages, the prevalence that we have
Yeah.
there.
Okay.
Perfect. Okay.
Tests.
Sorry, tell me.
Tests.
The test, okay, the test that has been performed to the patient, correct? Okay, I think that more or less we have identified at least the main ones, okay? So, okay, let me move to the next one. So, entities that can be represented in the example and problems that we have associated. First one, and probably the most important because it's the ones that will guide initially the diagnosis, as I explained. You remember that I explained this DCM model that was very simple, but I told you, okay, when you go to the physician, the first thing that you say to your doctor is what is happening, your symptoms, okay? So that's the thing, symptoms, but the symptoms can have subtypes. Fever is very unspecific, low fever, hyperpyrexia, intermittent fever, continuous fever. Exactly what do you have? Musculates, any kind of musculates involved, or do you have typical myalgia where, when you have influenza, that you feel like somebody fight with you and all your body is in pain. Negation, this is something that you didn't mention but never produced. You mentioned about the paralysis but never produced paralysis, okay? So this is something that it's basically negating a specific concept that has been identified. Prevalence, symptoms includes prevalence. In most of the cases we don't have this information, but that's reality. Laboratory test, serology, okay? Temporal information such as the incubation period, correct, or the treatment duration and the treatment information, the drugs to be used. I think that we cover all, okay, at the end. So, but how we represent this? If we come back to the previous answers that you give me about how to represent this knowledge, you give me basically two options. The first one was following the typical table, like in a database, okay? And the second one was the graph, okay? In this case, I opt for the graph for basically sake of simplicity in representing information, especially from a visual perspective, okay? This can be a representation of the problem that we have in this statement, okay? So we have the leptospirosis, okay? And we have this relation has symptom with paralysis with an operator that it's the negator, okay? So no paralysis, okay? We know that doesn't produce paralysis. On the other hand, we have two phases, okay? Phase 1 and phase 2. In the first one, the duration is between 7 and 12 days. Okay, and we have that belongs to this phase, okay, these symptoms: fever, chills, headaches, and muscle aches. For some of them, we have a prevalence, okay? We have also a set relation of intersection, okay, between the fever and the chills. On the other hand, we have a second phase where we have these four, let's say, elements, okay, that is conjunctival suffusion, neck rigidity, jaundice, and kidney failure, okay, and these are part of the second. On the other hand, we have the treatments, okay? We have all these potential treatments, and we have some, let's say, modifiers like the treatment duration or severe case treatment, okay? That means that in those cases, when it's a severe case, it's recommended to give this one. So this is a potential representation. It's not the only one. It's not a unique one. And this is something that we need to consider and to take into account. When we are talking about modeling, the modeling depends on how do you see the world, okay? And it's very common that different people see the world in a different manner. So this is something to consider, okay? That it's not the only one, but it's one that I think that can be let's say, useful or potentially reliable, okay? So this is an example of how we can represent knowledge, okay? In this case, the graph network-based representation are optimal in my opinion, but we need to decompose the terms trying to be or trying to reach the maximum atomicity as possible. So as more atomicity, more complexity that can have the model, but more difficult is to reach the comprehensive definition of the concept. So the reality is that as much atomicity, more in depth we are going, okay? So semantic technologies that probably you will see in the, I think that the next seminar by Oscar, I think it's about semantic technologies, and probably you will see some of these concepts are on good knowledge representation framework, okay? Different ontologies can be created to represent different kinds of concepts in the biomedical domain. So I have a question for you. I don't know, I mean, probably unless that you have been working on this domain, you will not know anything, okay? So there is no problem if there is no answer for this question. But there are several vocabularies and ontologies that are widely used to represent biomedical knowledge. Do you know any? Any of you have worked or have heard about any specific ontology, vocabulary, terminology? Okay. Sorry, my cat again, it's... Sorry. Well, I understand with your silence that no, okay, no problem. Okay, I will just show you very quick, okay? I don't want to stop too much here because it's just to let you know at least the name, okay, of these vocabularies, what are the main ones that exist, okay? One of the most important and largest that exists is called SNOMED CT, okay? The CT stands for clinical terms, and the SNOMED is something like systemized nomenclature of medical. I don't remember exactly what means the whole acronym, okay, but it's something like that. And it's a collection of medical terms that provides codes, synonyms, hierarchical classification and definition, and it is used in clinical documentation and reporting, okay? It's very, very famous and known by... my recommendation is that if you are suffering a global pandemic, which forces you to give classes from your home, get your cats out of the room, but I cannot get them out for some reasons. Sorry. Well, it's one of the most comprehensive multilingual, it's considered to be the most comprehensive multilingual clinical care terminology in the world. It's really used by many areas of the medicine, okay? It is supposed to be a standard, but it has different versions depending on the, cats makes the class more interactive. I partially agree. They make it, but when they are trying to go, over the computer, and I don't know if they will press some key that will stop everything, makes the things a bit difficult. But yeah, I mean, I love them, but for class, it's I think that I prefer them to be out. Well, as I said, it is supposed to be a standard vocabulary, but the reality is that there are several versions depending on the country. Okay, so in Spain we have, for example, a specific version. That basically is made because there are some concepts that can be, I mean, there are no concepts that are not universal, but there are some concepts or even codifications that can be specific on the country, okay? And that's one of the reasons. There are a couple of SNOMED CT browsers that you can take a look. You can find diseases, you will see the hierarchical relation and information that is useful, okay? These are some screenshots of these browsers, okay? Another classification is the one by the ICD. I'm quite sure that now, well, ICD is a classification promoted by the World Health Organization. I'm quite sure that you already knew about the World Health Organization, but now with the COVID-19, I'm more sure that now you know World Health Organization, okay? So the current version of ICD is ICD-10. Indeed, there is, I think, right now ICD-11, but I think that the most stable and used is the 10.1, okay? It has several subsets, like, for example, the clinical modification or the PCS, the procedure coding system, okay? Mainly, the ICD is used for administrative use, but has been also to describe a clinical picture of a patient, okay? It's used, as I said, as an administrative, basically to categorize the diagnosis of the patients in order to have, let's say, a reporting aspect of the code that provides ICD, okay? It has a section for mental and behavioral disorders that has been developed with the DSM. DSM is also very, very well known in the context of psychology and psychiatry. So this is an example of how ICD is organized. Again, we have like chapters, okay? Indeed, in ICD, if I remember correctly, and if it's not the case, Lucia probably can correct me, but one of the main classifications is based on the let's say not the organ, the system that is affecting the disease, okay? For example, neurological or circulatory or respiratory, something like that, okay? Based on this, let's say, initial classification, we can go in depth, okay? And we can go for the different diseases. And for example, you have influenza, okay? General influenza identified by the avian influenza virus, and they have several types within, for example, with pneumonia, with whatever, okay? There are, it's classified basically in a hierarchy that goes from the general to the specific, okay, in the child notes. MES is another vocabulary that it's mainly used with the aim of indexing journal articles and books in life science, okay? So it's more for a bibliotecary perspective, I will say. It's used by PubMed and Medline also as well as clinical trials to classify which diseases are studied by the trials that are listed at the page, okay? Well, we have here a structured example, for example, of the Alzheimer disease, and again, you will see that goes from the general perspective to the more specific ones, okay? Well, UMLS, it's UMLS indeed is a compendium of several controlled vocabularies. Indeed, SNOMED CT is part of UMLS, okay? In this context, okay, let me check the chat. Okay, I will answer you about your question, Gustav. Let me finish with this part, okay? And I will answer you because when I finish this part, I will give the floor to Lucia, but I will answer you before, okay? So, sorry, UMLS. No, it's okay. Don't worry. It's perfectly fine. But just to not break exactly what I'm right now telling you, okay? So it's a compendium of control vocabularies. As I was saying, SNOMED CT is part of this, of UMLS, and provides mapping between those vocabularies. Basically, UMLS is, like the largest, let's say, resource of codifications for in the biomedical domain, because as I'm explaining, we have different vocabularies there that covers different aspects of the medicine. For example, there is one that is RX norm that it's focused, if I remember correctly, to X-ray things. If I'm okay, MES that is more focused on the let's say, as I said, vocabularies regarding articles, scientific articles, books, etc. And SNOMED that is more focused on the clinical aspects, and ICD that is more focused on billing and administrative issues. Okay. So UMLS provides this relationship among them. A part of UMLS as a, let's say, compendium of vocabularies, there are other sources or other resources, for example, like software tools like MetaMap or SendRep that are really useful if you are working or dealing with medical data. Okay, indeed, we will talk about MetaMap later. The concept in UMLS are represented by a code that is the concept unique identifier, or CUI, that basically defines the concept. You have here more information. Okay. Another source of interest in biomedical semantic, in this case, vocabularies and ontologies, as you were asking, Ostan, can be found at these two web pages. One is OvoFoundry, and the other is Bioportal. Okay, and there you can find a specific ontology that has been focused to this topic. Okay, in terms of acquisition, well, the acquisition refers to the techniques or procedures that allows us to obtain, in this case, structured knowledge regarding the medical information in an automatic or semi-automatic way. Okay, so generally, the extraction of this knowledge is made from sources like text or images. Okay, the text normally contains information that is expressed in natural language. For example, the electronic health records from the physicians, okay, or scientific publications, or books, or something like that, or even social media. Imagine that you are talking about a disease in your Twitter, okay, or the physician is writing what happens to you in the electronic health record, or the scientist is describing a disease in a paper, okay? All these things are expressed in natural language. So it's important to develop methods and techniques that allows to accurately extract the information or the knowledge from those texts. Okay, these are the examples that I mentioned. So I would like now to ask you if you know any resource that provides you a relation of the clinical manifestation of a set of disease. I mean, I explain. Do you know any web page, any I don't know, any resource? I said web page, but any resource that can give you the relation between a disease, for example, leptospirosis, and the symptoms that are produced as part of the expression of this disease. For example, fever, jaundice, nausea, headache, vomiting, diarrhea, whatever, any symptoms. Do you know anything like that?
I guess
You mean
the
like
website
WebMD?
Sorry. Andy, first, for example, let me, Andy, know your answer.
Yeah. So like WebMD, I think I've used before. Is that the sort of thing you're talking about?
Okay, WebMD, but WebMD, I don't know if it has somehow a structured version of that or has textual descriptions of that.
Yeah, I think more textual descriptions.
Textual descriptions. I'm looking for something more structured, but this is a good point. Okay, to start. Indeed, it's a really good answer. Osta?
The World Health Organization always has like this kind of brief descriptions with diagrams, I guess.
Okay, but again, it's a let's say a resource that is somehow a bit unstructured. It's not the exact relation like I'm looking for, but it's again a good option. But do you know any other? More general, more like you can automatically go and say, okay, give me the symptoms of these 200 diseases or 2,000 diseases. Something that allows you to query in an easy way, you know, give me exactly the symptoms of this disease. Okay, that was what I was expecting. But indeed, I would like to one year giving this seminar to have somebody tell me, yes, I know one. This one is, you can go with a REST API and you can give or you can retrieve this, okay? The thing is that, I mean, there are resources like that, okay? Nowadays, there are some of them, but they are not so easy or so straightforward to reach them. We have some databases, okay? For example, OMIN, Orphanet, DiseaseDB, that are partially covering this idea that I'm trying to find, but they are difficult to access. They are focused on genetic or rare disease, for example, the case of Orphanet, or they have somehow, they have somehow incomplete information, okay? So imagine that we want to create a database with all the infectious diseases and their respective symptoms. This is an open question, but you partially already answered me, because, for example, how can you get this information? We can go to the resources that both Andy or both Ostap told me. Okay, you can go to WebMD, okay, and you can manually create one by one all the relationships between the diseases, okay? That's one option. But the thing is that acquisition of the diagnosis knowledge is harder. Why? There are several things that we need to consider. For the same disease, we can have several sources, and each source can contain different information. How can be this possible? Well, this is partially, I already answered this question partially a few minutes before. Imagine that we go to the WebMD to get information about influenza. We get, okay, we have this, and this symptom. And we go to the World Health Organization, okay, that Ostap mentioned, and they say, okay, we have this, and this symptom. For example, imagine that there is no a perfect matching among them. Why is this? I mean, it's the same disease. Well, because maybe the information that the World Health Organization is providing is based on a study that has been made on Europe, and maybe the one that is providing WebMD is a study that has been made on United States. And even considering that we are, we have similar genetic and environmental factors, they are not the same. The population are not the same, and there are clearly at the end some differences. Also, the countries themselves, of course, for example, climate effects or climate variables are not the same that can influence specifically, more specifically in diseases like the influenza, that is an stational disease that is affected by this type of variables. Okay, so this is something that can happen. The information of the diagnosis can contain several types of information, okay? And this is something that it's difficult sometimes to handle. The information expressed in natural language in WebMD and both in the World Health Organization will be expressed as natural language. Is really hard to process. Negation, interrelation, the correct association of semantic types, attach information like the prevalence or any other. It's not easy, okay? It's not straightforward. It is necessary also to extract information accurately, but it's also important to create a good knowledge representation schema. The example of the leptospirosis is a representation schema, but might not be the better one for a more general perspective where we want to model all the infectious diseases, okay? And this is something that we need to consider. Now I will answer your question, because I will start in the last part before giving the floor to Lucia. How often do you use ontology in our work? Indeed, we use it well. In my work right now, we are not using them too much because, to be honest, and in contrary to what I said before, we are using relational databases to store the information. There is a reason for that, and it's that the large amount of information that we are handling, we decided to switch to a, let's say, I would say more stable from the perspective that I am teaching databases, okay? I have been working all my life, let's say, professional life with ontologies also, but we consider also that we're clearer also because this work was done by a PhD student that had not expertise in semantic technologies, so it was better to focus on relational model, okay? But the thing is that, the ontologies, the problem is that you need to switch your mind about how it's represented, because in the relational model, that it's the one that most of the computer scientists or people that is working in ICT already know, it's more or less clear with the tables, columns, rows, clear. But the problem in the semantic technology is that you switch to this SPO, subject, predicate, object paradigm, where the relationships are made with these triplets, and they are not always easy to understand. Also because there are some concepts like the concept of class, the concept of individuals, that are really difficult to understand at the beginning. So I think that the problem with ontologies is that you need to have a really clear knowledge about the things that you are, about the ontologies themselves before going to them, before going to work to them. Because especially in the case of biomedical information, this is a problem that can be really hard to understand because of the concepts that we are using. Okay, so we are using them. We are using the ontologies indeed as part of some, let's say, exploration of data that we are doing, but not right now as a way to store information. This is something indeed that we are going to change, and I will explain you at the very end of the seminar today, because I will present you the system, this net, and I will explain you more about the things that we are going to do in terms of ontologies. Okay, so I hope that more or less I answered you, Ostap, but if not, we can come back to the topic at later. Okay, let me, because Lucia needs to leave, and I want to give the floor to her as soon as possible. So just to enter into the topic that Lucia will explain. Okay, big data. We were talking about big data, diagnosis, knowledge, etc. But what's the utility of having a list of the symptoms of a disease? Okay. Take into account that we have around 7,000 known or cataloged disease, but we only have cure, okay, for about 500. Consider that genetic diseases, we are not considered a cure for genetic diseases, because that means that we need to modify the genes of a person, okay? Something that maybe technology that like CRISPR might be able to do at some point, my CRISPR/Cas9. Okay, but now we are not talking about that. We are talking, for example, about diseases that are get by bacteria, by virus, or something like that. Okay, something by an external agent. So in many cases, there is no cure. We have a lot of treatments that are merely palliative, which means that we are treating the symptoms. Indeed, for example, in influenza or even in the COVID-19 at this moment, what are we doing? We treat the symptoms to try to stop, the effects associated to the disease, but we are not treating the disease. Okay, when you have influenza, you take paracetamol to treat the fever, to treat the myalgia, to treat the fever, myalgia, the cold, or any other associated symptom or set of symptoms. Okay, but even the palliative treatments are hard to find. Why? Because the development of a drug, why we should use big data to find cures? Because the development of a drug is a hard, expensive, and timely cost task, okay? Between 1,500 and 3,000 millions per drug, just 1 in 5,000 drug candidates make it all the way from the drug discovery to the licensing approval. Time to market can take up to 11-17 years. Okay, this is the normal path. Okay, we are now all experiencing a different path with the COVID-19. Indeed, it's with vaccines. That is not the topic that we are covering here, but of course there are many other things. Okay, here that affects. So these are the phases. Okay, that goes from the preclinical to the market. We're going to not focus too much here. So the questions that can be addressed from this perspective is, okay, how many diseases we have? Can we find a cure a registry for all these disease? Where? What information do we have? Are genetic? What is the gene responsible? Are caused by an external agent? What is the agent? It's a bacteria, it's a fungus, it's a virus. What is? Okay, can we get the symptoms that are associated to the disease? So the main problem that we have is we have a lack of information. Okay, much of this information knowledge doesn't exist, and we have different databases, interoperability problems, restricted access, difficult integration. But even considering that we have the data, how can we face it? Okay, even under the assumption that we have the data, what is the approach that we can use to face the problem of finding cure to disease. And this is the drug repositioning and drug repurposing. And now, let me please give the floor to Lucia. Lucia, 1 second. Are you there?
I'm here.
Okay, let me give you. Okay, no, 1 second. Okay. I think that now you should be able to share your screen.
I think so.
Well, Lucia is working with me at the Center of Biomedical Technology. Okay, she's doing the PhD with me. And now she will explain you what is the concept of drug repositioning, and she will explain you some findings that we got from a project that we are doing that I will show you just after the presentation from Lucia. So Lucia, when you want, I will mute and switch off my camera in the meantime, okay?
Okay,
Yours is the floor.
Thanks. Okay, 1 second. So Alejandro has just introduced a concept that is called drug repositioning or drug repurposing that we can use as synonyms, though they have few differences that we are not going to enter in the seminar. Drug repositioning is the idea of reusing drugs that already exist, that have been already developed for a disease, that are marketed and that you can buy it, and they are safe. They have been approved, so they have passed all these control phases that are quite restrictive by the agencies of drugs, like the FDA or the European Drug Regulation Agency, all of these agencies. So those drugs that are already in the market, we would like to give them a reuse. So use them for another disease, another indication, and that they can treat that new disease, and also the previous one, the original disease they were developed for. So the new use that we are giving to the drug is not costing us the amount of money, of time, of risk that we would be expecting if we develop that drug from zero. So it's just reusing drugs for already existing drugs for new indications that are different from the original indication that those drugs were thought for, okay? So here you have an example of the phases that go under the novel drug development to develop just one compound. So you can see that from 10,000 compounds, we will only get one compound at the final stage. And all these phases, these stages can take us, also Alejandro just said, maybe to 10 to 17 years. That is a lot, that is quite a lot. So the idea is to reduce those stages that are intrinsically from the novel developing drugs, and just having those stages that are needed for making safe that drug is going to be okay to treat the new disease that we have in mind. This is not, drug reposition, this is not something that we have, researchers have developed 2 days ago. It's something that it came out by chance because scientists discovered that some drugs were being useful for other uses that were not the primary uses that they thought of. And some examples of the first cases and some of the most famous cases are, for example, duloxetine, that was originally indicated for depression, but then was shown to be also good to treat urinary incontinence. Also, the retinoic acid that firstly was used for acne, and after that it was also demonstrated that it was useful for leukemia, for that cancer. Okay. This is probably the most famous one, that is Pfizer Viagra, that is sildenafil, that originally it was developed for angina pectoris, and after that it was seen that also was perfect for erectile dysfunction. So they started selling Viagra for erectile dysfunction instead of for angina pectoris, as it was thought at the first time. And also this drug, thalidomide, that I'm sure that you may know it because of those cases of pregnant women that took thalidomide and the children were born with malformations. But the thing is that thalidomide used it in not pregnant women, in all the rest of the people. It's safe, and it was first used for nausea, and it was that use that was given for the pregnant women. But now it has also been proven that it is okay for leprosy. Okay, these are like the most famous for examples of reproposed drugs, but they are not just the ones that have been reproposed. There are a lot. I have included here a lot of them, and as you can see, all the companies, all the pharma companies, that I'm sure that with the COVID-19 and this stuff you are more in touch with, like AstraZeneca, you can see it here, or for example Pfizer, I don't know, Novartis. Well, all of the pharma companies have used now that drug repositioning is known, to give new uses to drugs that they have already put in the market. So as you can see, the first drugs that were reproposed were in, for example, in 1992. So it was just a long ago, and it's an approach that it has been widely used till nowadays. Before we continue with this, I just want to have in mind some definitions, so everyone can go in the same part of the explanation. We are talking about diseases, about symptoms, about drugs, but I am going to make clear that here, when we talk about diseases, a disease would be the combination of some perturbation in the cell pathways, in the cell networks, that give a phenotype, and that can exhibit in the body several symptoms that we have been talking about in the previous hour. So when we talk about what drugs are administered for, we talk about indication. And indication is just a symptom that is given, a drug is given for that symptom. So when I talk about symptoms, indications, phenotype, effects, they are all the same thing, okay? But with the punctualization, that indication would be when I'm talking about what a drug is supplied for, okay? Another concept that I would like to share with you is also targets. Therapeutical targets. I'm sure that you also have some kind of idea about what a therapeutical target is. They are mostly proteins or some compounds in cells that, when we are talking about pharmacology stuff, would be the thing, the compound that the drug is going to affect to. So this way, the pathway or the network that is being dysregulated and that is causing the disease will not be as it was in the disease. It would be in a normal state, and we won't have that output that we consider the disease. Okay, so diseases, targets that are mostly proteins. We can consider also targets as organisms or maybe substance, but here, so you can understand me, we are going to see targets as proteins, okay? Also, we have symptoms that when we're talking about drugs, we say indications, and also at the biological level of diseases, we have the genes that may be causing that disease. Mutations in that genes are causing the disease. Also, that you have clear that from genes we have proteins, because genes are just the code that gives as output the proteins. Okay, so you can understand. It's like the DNA is just a sequence that tells the cells how they have to build a protein. So when we talk about genes and proteins, are more or less the same in the sense that proteins will be derived from genes, what we call the genes code the proteins, encoding the proteins. Okay. So knowing that, we have several ways to drug repurpose already existing drugs. There are several repurposing methods that are more in vitro or more screening compounds that we are going not to explain them now, because we are going to focus in the computational methods. Okay. When talking about these computational approaches, we can see the therapeutic action of the drug, which target is going to affect, and that target which output was producing. But we also can see the other parts of the disease process. Okay, when we say disease-centric, is based on the similarity of the indication of phenotypes that are treating that disease. Okay, so in the disease-centric approach, we could skip the part of the target and just relate the disease with the indication. Okay, then in the target-centric, we are going to study the targets itself and see if that target can also inhibit another symptom. And finally, the drug center searches in the molecule, because you have to think the drug as a molecule, and it has several parts. Maybe one of that parts in the molecule is going to bind to a target, but maybe another part that we are not taking into account of the molecule can bind to another part of another target, and also inhibit another metabolic pathway, for example. Okay. What we are going to see today mostly is this table, but okay, because this one is based more in the structure, in the proteins structure, and is more oriented to physical chemical informatics. Okay. So we want you to think if the diseases that have been involved in drug repositioning cases share elements in the phenotypical level, or do they say they share elements in the biological level? So we have to pose that question to us to research in new possibilities in drug repositioning. Also, another thing that we have to think when drug repositioning is, are repurposed drugs therapeutical targets related to those genes and proteins that were related to the disease? So two diseases that share genes, and that gene is part of a therapeutical target of a drug, could those diseases be treated by the same drug? How can we predict new cases of drug repositioning? So those are the questions that I want to explain a little bit. How can we deal them? Like, how can we face them? Okay. First of all, before doing anything, we like to explore a little bit what the cases that have been working in drug repositioning are. So for that, we know some cases, as I showed you in the previous table, of drugs that have been reproposed during time, and we want to have a list of them. So we build a list of those triples where we have two elements: the drugs, the original disease to which this drug was developed for, and then the new disease to which the drug has been reproposed. So we have those triplets. We extract them from the literature, like from just one article with a table similar from which I saw you. And doing a little bit of filtering because, as Alejandro has explained, there are a huge amount of terminologies and standardization in medical informatics and also in biology. So here the most difficult part is to standardize everything and to understand between the different information that we have that can map into each other. Okay, so we did a first iteration of analysis to validate our data that Alejandro will later explain about DISNet, but this was to validate DISNet as a tool to drug repurpose. Okay, so imagine that we extracted 34 triplets from the literature. After doing some pre-processing, we obtained 19 triplets with 10 different drugs, 8 different new diseases, and almost also 19 original diseases. So you can imagine the list of triplets. From those list of triplets, what we did was to search which genes and which symptoms they had together. So to look how much similar were the original disease and the new disease, so we could prove that those repositioning cases were by chance intrinsically were because the two diseases had similarity, and in a future we could do the direct, in fact, approach, not the inverse. That is what we are doing here. The direct, that would be studying all the diseases, combination of all the diseases with all the diseases, and seeing which diseases were more similar and treating them with the same drugs. So if a disease from those pairs didn't have a drug, it could be treated with the drug of the other disease that is quite similar to the first. So this is the idea, to validate that sharedness in the phenotypical, let's say, symptoms level and in the genes level, in the biological level, can give us a clue to drug repurpose. Okay. And in fact, when we did the first iteration, that we just had 19 triplets, well, that is nothing, too low number of triplets. We saw that, for example, good and familiar Mediterranean fever shared 18 symptoms. These two diseases were treated by colchicine. That is also a known case of drug repurposing. Firstly, was used for gut, and it was shown that also for familiar Mediterranean fevers was okay. It worked. These both two diseases are in class ICD-10 that Alejandro was explaining ICD, musculoskeletal system and connective tissue. It's interesting to see if those known cases of drug repurposing show patterns in the classification of the diseases and the drug. I mean, do we have also always cases of drug repositioning for an original disease that is from the circulatory system, and a new disease that it is from infectious agents, and then also the drug is always an antihistaminic. That is a little bit crazy, okay? Biologically, it doesn't make too much sense. But knowing these patterns, in a future, we could do it the other way, as I was telling you. If we have one disease that is treated with one drug that is already approved, that we know that it works correctly for that indication, and that disease is from the circulatory system, and then we have another disease that is quite similar because it shares a lot of symptoms and a lot of other things with the first disease, and is from the infectious agent. Can we use the drug originally indicated for the first for the second? And if we could, we would develop a very cool system or platform that would give us a clue of which drugs could be repurposed. Okay, I have gone through a little naive explanation, but so you can understand. Okay, so here the colchicine, for example, that is a known case of a repurposed drug. We saw that 18 symptoms were shared between the original disease and the new disease. And also they shared 2 genes. Okay, this was until here because we needed to expand the list of triplets. Once we did it, adding manually from the literature, also more tables that we found, and then we had to qualify them because normally they were as names, and we need something standardized so we can match with the information that we have. At the end, there were 247 triplets. Okay, from those triplets, we could do this analysis that we were talking, and because we had so much information, we wanted to know if we could give somehow a probability to a drug to be repurposed. To this, we had a score of association between diseases and genes that is from a platform called DCNet. And it is between 0 and 1. 0, they are not very related, and 1, they are highly related. Okay, so a disease would be very, very related to that gene. Mutations or whatever in that gene would be associated with the appearance of that disease. And what we did was to see if those triplets, the disease that was originally indicated for the drug was very highly related to the target that was affecting the drug too. So, as I said, we have to think of the targets as proteins that come from genes. So that score that I was talking about can be seen as the relationship between the disease and the target of the drug. We saw that most of the original diseases and the new diseases associations between the drug target and the diseases were very high in comparison with all the disease gene associations. So this proved that there was a correspondence between the score in the triplets, in the cases that have been reproposed, against all the associations between disease and genes. What I want to say here is it is more probable of a disease to be related to a target that is going to be shared with another disease to be reproposed than the rest of diseases. Okay. We did something similar with the symptoms, but here it was not so evident because the score that we had here, it was something like the prevalence that we were talking about, it would have been better, but we had something else and a score that was most about the information that we kept along the time. So it didn't make so much sense biologically talking, okay? Okay, so some interesting case that we found here was the drug bromocriptine, okay? That is, it was originally used for Parkinson's disease and then was reproposed for diabetes. We saw that these two diseases shared 100 genes, but between those genes, it was the target that drug was affecting when it was treating that disease, that it was the dopamine D receptor. It was shown that both of the diseases are involved with that gene in the homeostasis of glucose. Okay. So this is what I was telling you before, that it is also very important here to have in mind the classes and the taxonomies, not only for the diseases but also for the drug class, and to search if we can make patterns and see if something is more probable or less probable to be reproposed. This was a paper that was published last year, where they saw, here they used another classification. It was not ICD, it was MENS that we have been talking. They saw the number of reproposed drugs between the classes of the original disease and the new disease, what they call here original indication or new indication. And you can see which combinations of original indication, new indication have been highly reproposed. Once we have this, that is kind of validating the direct analysis of the indirect analysis of drug reproposing, we can do the direct, because the other way around. It would be great if we could have a system that predicts the new uses for already existing drugs, but not only predicts it, but give us a percentage or probability of being reduced. But this is what we are developing right now in the lab. So once this is like, okay, we have something that it is good to drug repropose. We have the data and it works. Now, how can we treat how can we propose for treating COVID-19 with this data that we have, that we already know that is useful to do this? So I wanted to ask you very quickly if you know already any case of drugs that have been reproposed for COVID-19. There are two that are quite famous and that have been talking about.
Paracetamol.
Well, that one I wouldn't say that it has been reproposed for COVID-19 because it has been used for COVID-19, but I think there are other cases that are more, let's say, okay, one second.
In the chat, Lucia Delfina says remdesivir.
Yes, that one is the one that I was. Yes, remdesivir. It was the one that I was wanting to ask you about. Is some drug that it was already approved for SIDA, for HCI, and that was proven to work for COVID-19. Now it is kind of they don't know sure if it is okay or not. Another case very famous is dexamethasone, hydroxychloroquine and dexamethasone. But the only one that has been approved was remdesivir. Okay, and all of the Trump this craziness about buying remdesivir, but scientifically talking, it was because they saw that because it shares some pathways with the infection of COVID and something in the infection, it could work also for COVID. I mean, researchers proved that it could work. It was not some allocated idea, some crazy idea or whatever. Okay. Also, I'm going to go a little bit faster. This is the pipeline that we are proposing to repropose drugs with the data that we have. To simplify, they are just little paths of information that start with COVID and end with drugs. The three of the upper part go from COVID symptoms, and path 4 and path 5 start from COVID genes. Okay. So also you have to think first what is COVID. Okay, I think everyone knows more or less what is COVID. It's a virus that is from the coronavirus family that has proteins that bind to cells in the human body, so they can enter in the cell and they replicate because they have a one strand positive RNA, whatever. But informatically talking, there are several entities that can be considered as COVID-19. Here I'm showing an example of the different identifiers or the different concepts that are related to COVID. I mean, coronavirus disease 2019, coronavirus infection, SARS coronavirus. They are like upper hierarchy of coronavirus, but then COVID-19, coronavirus disease, COVID-19. I mean, they are all representing COVID, but are differently identified. Also, one thing that you have to keep in mind is that this is the same problem as always, that we have several terminologies and vocabularies, and one vocabulary is going to represent it one way, and another vocabulary is going to represent it other way. But at the end, they are the same, and we have to somehow say our system that these things are the same. Which are COVID symptoms? Anyone? Okay. Fever. One very specific for COVID is anosmia. That is when you can't taste or smell the food or whatever. Also, here we have the same problem. Where can we get these symptoms? There are several sources, and some of them can be accessed by APIs, as we were talking, or text-mined, whatever. But we need a list of those symptoms that we were talking about. Also, which genes are related to COVID? This is, as we are in an early stage of the disease knowledge, we yet not have concentrated knowledge. Okay, we need to mine publications or webs or whatever to see what the scientific community says about it and associated to COVID. So here are some of them. The most famous one, I'm sure that you have heard about, is the spike glycoprotein that also is called surface, because it's the one that is in the outside of the virus, and it binds to the membrane of the cell. And the other proteins that are in the cell, not in the virus, as AC, that is the receptor, the one that binds to the spike protein. These all are genes related, not genes all from the virus, but genes related to the disease in general. Okay, so from one side we have the symptoms, and on the other side we have the genes. From the symptoms, what we can search are the phenotype effects that, as I was telling you, are the indications that are related to the drugs. All this information is coming from public sources. I'm not going to enter, but we have it all structured in a relational database, as Alejandro was saying. And the thing here is that the amounts of data are huge, and to discern which are the most probable drugs, we have to intersect all the possibilities in the pathways that I have shown you. So the idea of doing this is to search which drugs have all the common pathways to COVID, and those drugs that are intersected will give us that a high probability, because they are not only related to symptoms related to COVID, but are also related more or less, let's say, to genes and to diseases that share symptoms with COVID. So in a way, we are narrowing the set of drugs that can be used. So I'm not going to go too deep into this, because I think it's not quite relevant, but just you can see that connecting the information and searching in all the possibilities can give us new uses for drugs that already exist and that we don't have to develop from zero. At the end, what we obtain from the 5 pathways the intersected drugs in all the ways of information were these. Searching in the literature, we have seen that all of these drugs, except from one that I want to tell you later, are involved in either the virus mechanisms of entrance in the cell, or either in regulating the body immune response. So if we have a cytokine storms, we don't have the levels so high that it's going to affect our organs. Things like this, okay? So it has been proven that yes, these pathways of information can show us possibilities in COVID-19 reproposable drugs. Also, once doing this, the thing is that yes, they are potential to be reproposed, but always at the end they will have to be tested that in vitro, so in a wet lab, let's say, if they exactly do what we are, let's say, imagine they do, okay? The only drug that wasn't in the literature state to be a possible drug to COVID was the second one, the aldesleukin. Okay, this is an orphan drug. An orphan drug. What is an orphan drug? It's a drug that is used for orphan diseases, rare diseases. Sorry. So this is very interesting because as it is an orphan drug, it will be very low produced in the way that very a low number of people will need this drug, because a very low number of population will be affected with the disease that is treating this drug. That is concretely a rare type of cancer, the renal cell cancer. So if at last it is demonstrated that this drug could treat COVID-19, it would be like something good, because a drug that has been developed for a rare disease, which is bad for pharmacies, because for pharma companies, because they give less money than other drugs, it would be good because it would be a lot more produced, and therefore pharma companies will gain more money. It will be good, understand me, not for me, not for you, for pharma companies, but yes, that is the idea, that a drug that is almost forgotten because it is used just for very quite low as people, can be used for more people. So this is the end. This I have already told you that most of the drugs that I have shown you have been reported in the literature, and also we have, for example, chloroquine that was proposed some months ago to be a good treatment for COVID, although it has been dismissed because it has been shown that not really good. No representative changes were made among the control population. Okay, so yes, I think for my part this is all. I don't know if you have any question. Sorry for my English.
Well, if you have any question, we can. I think I will try to solve it in any case at the end. That I know that you need to leave, Lucia. So don't worry. Okay, I will handle it. Thank you. Thank you very much.
Bye. See you.
Thank you. Okay, so I will continue. Okay, after this part of Lucia, we'll continue with the final part of the presentation. Can you see my screen again?
Yes. Yep.
Yes.
Okay, well, let
Yes.
me move all this part from Lucia. Okay, and okay. So, well, after Lucia explained you how, first of all, I would like to say that this work that Lucia has shown is something that we are doing at my lab. That, by the way, I didn't say anything at the beginning. Well, my lab is at the Center of Biomedical Technology. We are the medical data analytics laboratory, and we have many projects that are related with basically analyzing data from several perspectives. Some projects are dealing with NLP and electronic health records to later on analyze the data from both descriptive or predictive perspective. And for example, this project that, well, these results are from a project that is called DisNet. Indeed, in some of the figures, you already saw the DisNet, that it's the final thing that I will mention at the end of this project, of this slide. I'm sorry that we did it like this. Lucia showed the results first, but she needed to leave. So we did it like that. But the thing is that the perspective that I start asking that was, how can we do this drug repositioning from a computational perspective where Lucia has shown this result, is based on the concept of human disease networks. Okay, any of you have heard about that, about a human disease network?
No.
Okay. Well, it's the most normal thing. Okay, it's like in the vocabulary. This is a very, very specific concept. Well, this concept this concept is based on the idea of networks. Okay, that at the end is related with the concept of graphs, where we have different types of networks. Okay, depending on how the randomness is increased, we are dealing with regular networks, complex networks, that it's OR case, or what is called random networks. Okay. The concept of human disease network was a concept that was coined in 2007 by several authors, including Albert Laszlo Barabasi, that it's a very well-known physicist working in the concept of I would say of complex networks. Okay, in a paper that was published in PNAS. Basically, HDN is a graph where the diseases are related based on their similarities. Okay, and what are these similarities? Well, the idea is that the similarities between two diseases is calculated under the assumption that they are sharing something. Okay, some characteristics. In this paper that was published in 2007, as I said, they based their approach in disease gene association. So the idea was, when two diseases were sharing a gene, okay, they have some relationship. As much genes as they were sharing, more similarities or more relationship exist between those diseases. Okay, but this is a concept. It's not the unique that it's available. Okay, this concept of HDN, as you can see, we have the nodes and we have the edges. Okay, and the edges are bigger. Okay, are thinner as less genes they share. Okay, and on the opposite, it's bigger, más grueso. I cannot find the word bigger. Okay, as much genes they are sharing. Okay, so that's the idea. However, 7 years later, in a paper published in 2014 in Nature Communications, again by Zhu et al., including this guy that I mentioned, Albert Laszlo Barabasi, they propose an extension of this concept of the human disease networks with the human symptoms disease network. Okay, and this approach and how they focus the approach open a new horizon in the possible knowledge that we know about the diseases. Okay, basically, they just set up or propose a hypothesis that it's quite simple. If two diseases have shared symptoms, maybe they are having or they are sharing some molecular interactions. Okay, underlying molecular interactions. So if they are sharing some biological components or information, okay, and these can be both genes as they did in the HDN, or the proteins that are codified by those genes, or the interaction between the each proteins codified by these genes. okay, that might imply that they have an additional component of interaction or of connections. And this can, let's say, with information, we can create new hypotheses about these relationships. So this is the idea that they basically establish, okay? The symptoms establish some connections between the diseases, and as much symptoms they have, more interesting is, let's say, this connection, okay, or these similarities. And on the other hand, we have the genes and the proteins or protein-protein interactions also to define the biological associated similarity between the diseases. And one of the most interesting hypotheses that they mention is, if we have one drug X that is used to treat the disease A, and we found that this disease A it's similar to another one, disease B, okay, based on this symptom or biological similarities, is it possible to say that drug X could be used to treat disease B? And this is basically the idea of the drug repositioning that Lucia has been explaining, okay? The thing is that this kind of hypothesis has been, let's say, widely demonstrated in the literature in the last year, in the last years with regarding this concept of HDN. That can be possible, okay, to, let's say, establish this kind of relationship. However, the problem that we found when we, well, the problem that I will not say that I found, the problem that I identify, or from my perspective as computer scientist, is that the approach that these guys use to create the HDN could be improved from the perspective of the computational approach used to define the relationship between the diseases and networks, okay? Basically because they were using an approach where they analyze the information that was contained on scientific publications, but more concretely on the abstract of scientific publications, and using to extract the potential symptoms or potential findings that are associated to a disease, the vocabulary that we saw before that was MESS. But MESS is a vocabulary that it's very useful to classify articles, but I will say that it's not as much useful for identifying potential and interesting symptoms or findings in a paper. Moreover, they were focusing on the abstract that, as you know, is a very small piece of information in the paper that summarizes the content, while the paper itself may contain much more information. It is true that may also introduce much more noise. That's a reality, okay? But that's a potential problem that can be also handled. And finally, using powerful text mining techniques or natural language processing techniques can be an option to, let's say, try to improve the knowledge acquisition from this source, okay? So what we propose in our project, that is this net, and I will explain later more, it's to create a multi-layer network, okay, that makes basically reference to a kind of network where we have, in this case, 3 different type of layers. In the first one, what is called the disease data, we refer to the phenotypic data that are the symptoms or signs, laboratory procedures, laboratory tests, etc., that define a disease. In the genetic data, that I will rephrase as biological data, it's the information that is biological, that can be genes, can be proteins, can be molecular pathways, can be SNPs, can be any other type of biological information. And finally, we have the drug data, that is the one that is related about the treatments that are used to treat those diseases and how are related to the diseases or to the phenotypical effects or even to the to the biological information, and all interconnected. So, well, the thing is, how do you think the data can be retrieved? I will answer directly, okay? In this case, for the phenotypic layer, what we used was natural language processing, okay? The idea is that the medical text contains information that can be used, okay, to create, for example, diagnostic knowledge bases. We were talking about this diagnosis problem where we need the relationship between the diseases and the symptoms, okay, or the findings or any information that can be used to diagnose the disease, okay. Some of the most classical texts about medicine, like for example, there are very well-known books, at least in Spain, I don't know in other countries, that is Harrison's or Farreras, that are books that basically describe diseases in several aspects, including in the clinical manifestations that are the symptoms, okay, have information about the disease in a, let's say, semi-structured way, okay. It is true that it's a natural language text, but they have some clear section that differentiates the information, okay, like this one. So the clinical manifestation sections in these books can be useful to create the diagnosis knowledge base, okay. So there are available several interesting sources of public information. One of them is Medline Plus. And this is an example of Medline Plus that can be something like WebMD that you mentioned before, or the one from WHO. So from WHO, World Health Organization, okay? So we have, for example, here the definition of a disease that is impetigo, okay? And impetigo, we have some causes, we have some symptoms, exam and tests, and treatments. So with, PLN, el procesamiento de lenguaje natural, we have the acronym in English and Spanish, my fault. With NLP, what we can do is extract relevant entities from the text using a part of the NLP process that is called name entity recognition. Okay, name entity recognition basically is to identify those words or set of words, it can be more than one, that makes reference to a specific type of entity. In this case, the type of entity that is interesting for us are the symptoms, are the signs, are the laboratory tests, or are the laboratory procedures. So if we apply those concepts to the Medline text plus text, what we will have is something like that, okay? This is something that we did manually, okay? So that might be one of the relevant options, one of the options that provide relevant information. We have symptoms, okay? One or many blisters, filled with pus and easy to pop. In infants, the skin is reddish. Blisters that itch, filled with yellow or honey-colored fluid. Rash, skin sores, swollen lymph nodes, okay? So these elements basically are defining symptoms and some characteristics or modifiers, okay? In infants, the skin is reddish. The blisters that itch are filled with yellow or honey-colored fluid. So we have, on one hand, the element and some modifiers, as we did in the leptospirosis example, okay, that we did it manually and we create our model. This is a, I will say, perfect scenario, okay? The reality is that the techniques that we are using right now are good, but are not as good. Also because right now we are only focusing on extracting the entities, not the modifiers of the entities, that it's important and really relevant, not the relation between the modifiers and the entities, okay? What is the relation and how I know that this skin is reddish in infants makes reference to the blisters that, by the way, blisters that itch, that, by the way, are filled with yellow or honey-colored fluid. So this is important, but this is difficult also to handle. So NLP, I will not focus too much on that, but the idea of NLP is basically a process or techniques and algorithms that process the text expressed in natural language and allows them to divide, categorize, and classify. So the idea is structured information from natural language to a more structured version, like can be a table or a graph or something like that. Okay, so this is the idea of natural language processing, okay? The idea is to detect, so for example, detect the nouns, the adverbs, detect the relationship, detect, for example, if there are some information that is negated, detect the speculation, detect everything, okay? And there are several steps that are done in this, from the segmentation to the tokenization to the part of speech tagging, that is this part where we detect the noun, the verb, the adjective, etc., to the entity detection, that is where we detect that, for example, if we have a text that is mentioning fever is a symptom. And if it's mentioning right leg, we know that the right leg is an anatomical part, okay? It's related to anatomy, okay? It's a part of the body. So this thing, and if we are talking about Spain, we know that Spain is a country. And if we are talking about Alejandro, we detect, or we are able to know that Alejandro is a name of a person, okay? So this is the name entity name entity recognition detection. And we have the relation detection, that is when we are talking about Alejandro fue al médico, Alejandro goes to the physician because he had fever, and finally he was diagnosed with COVID-19, okay? The idea is that Alejandro goes to the physician, so we relate that Alejandro and physician is connected because between a specific relation. Alejandro had fever, so Alejandro and fever are related, and finally Alejandro diagnosed with COVID-19. So we have Alejandro that is related, Alejandro as a name entity recognition, as an entity, is related with another 3 entities through 3 different predicatives or types of relationship, and this is the relation detection, okay? It's a really complex task, the NLP, okay? How we approach the extraction of information from text like in Medline Plus? Well, what we did is that we use MetaMap. If you remember, when I was talking about UMLS, I told you UMLS is a compendium of vocabularies, but UMLS also provides software tools that are relevant and interesting. And I mentioned 2, SEMREP and MetaMap. MetaMap is this tool that can be used to perform NER over medical text, not only NER. Indeed, MetaMap performs NLP, but here we were focused on the NER task, that it's the one that was of, let's say, firstly interest for us. The process is easy. Think of it. You just load the text, apply the semantic types that you want to obtain, and this means, okay, I want to get symptoms, laboratory tests, laboratory procedures, and anatomic locations, okay? The semantic types are the categories of the types of concepts that you want to retrieve, okay? The idea is that you execute it and you get it. But however, the problem is that MetaMap sometimes return incorrect results. An example, if we have red lymph nodes, MetaMap can return red as a finding, and it is not. Red in this context is a modifier that it's basically telling you, okay, your lymph nodes are red, are in Spanish is enrojecidos, that means that they have a red similar color, okay? So this kind of thing needs to be improved. To improve this, we developed some things that I'm not going to explain here because it's too much, but just a final consideration, the tools such as MetaMap can allow us to make an extraction of this type of information and create this HSDN, okay? But it is true that more advanced techniques and frameworks can also be used. The idea is that when we apply MetaMap, what we get basically is something like that, where we are able to have the diseases associated to symptoms, and then we are also able to, not with MetaMap, with other tools and other techniques that I will not explain too much here, we are also able to get the genetic and the drug data, okay, that will be in those layers. This is an example of some of the problems that we can find when we are applying, let's say, the idea of having a definition of a disease that came from different sources. And I just mentioned this some minutes ago. If we are, for example, when you mentioned the WebMD and the World Health Organization pages, I told you, okay, if we go to both pages and we are going to see, for example, what we have on the influenza page, what we will find by sure is that probably in the influenza page of the WebMD, we have some symptoms, and in the World Health Organization, we have others. And I explained you that this is because probably the subject of population use or the scientific papers where this information came from are from different populations or different studies. And this is an example of this, okay? We have here, and this is something that it's real, we get the definition of the Q fever, okay? that it's a disease, from the CDC, okay, from a paper that was published in the Journal of Clinical Microbiology, if I remember correctly, and from Medline Plus. You will see that, for example, we have some symptoms that are in common for the three headaches, but however, we have that in the first two, we have high fever as a symptom, but in the third one is fever, which is not semantically the same, and indeed there is no a direct match, okay, at least automatically. We can think that high fever can be the same somehow, but the reality is that they are not, okay? And there are others like jaundice that only appear in one, optic neuritis only appear in one, chest pain only appears in the first and in the third, jaundice only appears in the third. So at the end, what we have is something like that we go and we can define the Q fever as the combination of all the union, okay, but each symptom came from a different source. And with this, there is something that really interesting that we can do, and it's make an analysis of the definition of a disease considering several unions or intersections of the symptoms that are produced in the different sources. For example, in the B, we have all the symptoms that only appears, okay, as part of as only one source, okay? Jaundice and optic neuritis only appears or in the GCM or in the Medline Plus, okay? So the others means that are in common. In the, for example, first one, we have only the ones that appears in all. Considering, for example, that high fever, it's the same, okay? But if not, only headaches is the one. And we have several other combinations that can be done. And this is really interesting because allows, from a really big data perspective, imagine that we have a lot of sources. We can do a lot of analysis with these combinations to try to focus on seeing the difference between the sources or on seeing if, for example, it's interesting to consider only the symptoms in common for an analysis or all the symptoms that we get from all the sources, like it's the case, for example, that we have at the there where all the sources has been included, etc. And just to finish, okay, with this, we will finish the seminar. I would like to introduce you the results of this, all these things. So I have been talking for, between me and Lucia, like 2 hours and 20 minutes, more or less, at this moment, okay? And we have been talking about the diseases, how to, I mean, what is medical informatics, what is a disease, how is a model, a lot of things, okay? We have been focused a lot on this, especially on this part, the final part, on drug repositioning and the concept of human disease networks that allows me to create a model where I can relate diseases based on these definitions, but also a model where we can define diseases. I mean, the results of all this research is this project, DISNET, that is a project that at this moment is funded indeed by the national government from Spain. It's supposed to be finished this year, okay, at least the funding. And basically the DISNET is a framework or a platform that was created with the aim of retrieving this information, phenotypic and biological, from public sources, both structured and unstructured. And the idea is to provide to the researchers a database of disease information that allows them to have a better understanding of the diseases. I asked you at the beginning, when you mentioned me WebMD and the WHO, I asked you, do you know any platform or system that can give you, given a disease, the symptoms? Okay, WebMD, who? Okay, but can you give me one that is not on text? I will give you one, DISNET, okay? This platform now is able to answer this question and it's able to give you this data. The web is available at this, I mean, the platform is available at this website, disnet.ctb.upn.es, okay? This is basically the high-level architecture. I will not focus too much on this. It's better this one, but the idea is basically we have public internet sources where we are able to retrieve the text from them, okay, the text that define a disease, and from this text we are able to apply this MetaMap process, okay, MetaMap and TVP, that is the process of validation that we have, this NLP process, to basically at the end have a database where we have the disease and all the symptoms that are part of the definition of this disease. But also we are able to add both biological and both drug information at this moment, okay? I will explain a little bit about the drug and the biological at the end. Forget about this TPP because I'm not focused too much. This is, for example, a representation of two options. One, we have the acrodynia, that is a disease, and all the symptoms that define them. And in the other, we have a comparison between the gastroenteritis and the influenza. And we can have the symptoms in common or the symptoms that define them separately. This visualization indeed is this visualization was done not manually, but was done with a specific software. But the reality is that right now, and I will show you later at the very end, a quick example, is that now you are able to use or to see the visualization in the DisNet platform, okay? The current version, this is the last year data. I was not able to update it, sorry, but in the last year we had near to 25 million registries. That was around 6 gigabytes of data from 3 sources, Wikipedia, PubMed, and Mayo Clinic. And only Wikipedia contains 70 snapshots, okay? About Wikipedia, I would like to mention something. What we are doing in Wikipedia is, I think, that's quite interesting, because in Wikipedia, we are going to the disease articles, and as it happens in those books that I mentioned, Harrison's and Ferreras, Wikipedia articles about diseases, normally they have sections where they define the symptoms of a disease, okay? So what we are doing is that we go to the Wikipedia, but we go to these sections, we extract the text from these sections, and we are able to define the disease, okay, based on this data. We are doing this, the extraction of the information 2 times per month, which makes us also capable of evaluate and analyze the temporal information of Wikipedia and how it's evolving. Indeed, we have a paper published about that, and it's quite interesting seeing how the Wikipedia information evolves over time. And this is something that might be worthy to take a look if you are interested on this type of analysis. Just to almost finish, the biological information has been recently added, okay? I didn't mention them too much because, to be honest, it will take much more time. Indeed, this is something that we did last year, but we didn't mention all that Lucia presented today, and we have like 20 or 30 more slides about this, but I just omitted for this year. I just want to just show you, give me 1 second, because I would like to show you the visualization of this net, just to let you know somehow the potential that at this moment has this platform for us. And this is just a very brief example. If you go to this net, you go to visualize data. For example, we can search by disease. So we can select the source. I will select Wikipedia, okay? For example, I will find the last, okay, I don't know why. Okay, there are some snapshots that are not available, but I will here, and I will, for example, influenza. Okay, influenza here. I don't know if here in this snapshot I have coronavirus. Maybe not. Okay, maybe by COVID. Wait, because I think that there was maybe in this snapshot. Wait, because I need to. Okay. COVID. Yeah, COVID in pregnancy. No, I just want COVID, coronavirus disease. Okay, and influenza. Okay, and I will try to see symptoms in common. Okay, and these are, for example, the symptoms that influenza and coronavirus in this snapshot, okay, in this source find, okay. For example, illness, okay, it's too general, it's a term that it's just disease, of course. Coughing, pneumonia, infection, and fatigue. Okay, and on the other hand, we have much more that appears to be part of the influenza. Okay, cyanosis, headaches, chest pain, etc., and others that are part of the coronavirus. As I said, for example, it's for me now a bit surprised that something like that diarrhea or probably here, well, indeed in this table we can see, I don't know. Okay, this is the symptoms in common. Okay, not all not all separately, but in the symptoms separately, probably there are some others that should be or should be considered as that should be in common. But of course, this depends on the information that we found on the snapshots. Okay, there is other options in the visualization that, for example, well, here I don't know if we'll give any result, but the genes in common. This we can select the sources that we have from genes. Okay, I don't know, it will be something in common between the coronavirus and influenza. Okay, it seems that there are no common genes, so it shows, okay, the genes separately. Another option of visualization of data is this one that I really like, that is search by symptom. That, for example, imagine that headaches, nausea, diarrhea, jaundice, for example. No, jaundice. It seems that it didn't find jaundice as any of the available symptoms. Okay. What else? What else? Tell me any symptom. Something common. Okay, not very, because these three
Fever?
are. Tell me, Andy.
Fever?
Fever, yeah, sure. Fever, chills. Okay, maybe with this, let's see. What is intending to provide here is the diseases. Okay, here, well, the visualization is not. Is the diseases, okay, that has each of the symptoms, okay, but we can see also here the combination, okay? So chills, diarrhea, fever, headaches, and nausea, it's all these diseases, including, for example, by the way, the leptospirosis, okay, that I had. So this is an example of, for example, this is an example of the use in the context of a diagnosed system, okay? Because you introduce the symptoms and it is telling you all the ones that are in common, okay? Here you can also select different combinations. Okay, so here with only diarrhea you have all of these, only with nausea you have all of these, and you can move. Okay, but with all these symptoms in common you have all these diseases. Okay, here, yes. So that's another of the functionalities that we have added at this moment to this net. A part of that here, it's explain the API, okay, that has been developed, okay, to get all the information that is available at this moment, that is the phenotypical and the biological. And here you can log in or sign up in order to use the system. Okay, it is required to register to use the system. We did it like that because we want to have some statistics about the use, but basically, well, it's just to have some information. So, well, these are all the slides that I hide regarding the biological information. So finally, well, with this, I conclude, okay, the seminar itself, my presentation. I would like to first ask you if you have any question. I will be happy to answer. And after that, I will just explain you very, very, very brief, okay, the assignment that that you need to do. It depends on your specific master, okay? Some of you only with attending it's enough. By the way, let me take a screenshot of the participants because Javier told me that I need to have the list of the participants. Let me do it very, very quick. F1 until here. From Fiona until Thomas, F2. In the meantime, any question?
I have a question about DisNet.
Yes.
Why did you need to pick up a date to make your research?
Sorry, can you repeat?
Why did you need to choose a date for the research?
Why you need to choose a date?
Yeah.
Okay, that's a good question, because DisNet is a platform that is taking information every, in this case, in Wikipedia, every 15 days. In the PubMed, we only have one date, so I think that it's not necessary to pick up to pick a date. And in Mayo Clinic, I think that every 15 days is done also. So that's the reason, because you need to choose a date, okay? Because, for example, imagine in Wikipedia that it's the most probably easy way to understand or to explain that. In Wikipedia today, you have information about coronavirus specific, but imagine that tomorrow there is a news about a new treatment that works perfectly with the coronavirus, okay? Or imagine that tomorrow there is a new evidence of a new symptom of coronavirus. In this happens. If you remember when the COVID-19 started, well, at the beginning was, okay, it's like an influenza, but then, okay, it's an influenza, but one of the most relevant symptoms is that you lose your smelling and your taste. And then there was another symptom that whatever. So Wikipedia is updated by the people. You know, you can update Wikipedia. So tomorrow, maybe if there is a new evidence about a new symptom, Wikipedia will be updated. So if you try to find information on Wikipedia 15 days ago, and tomorrow the information will be different. So that's the reason, because you need to pick a date. The reality, this is for the visualization, okay? And for the API also, but the reality is that indeed this is really powerful, because allows you to evaluate or to analyze the temporal evolution of the information. So indeed, this is something that we did. I will update the webpage of the seminars, and I will give you a couple of references of some papers that we did with the use of DisNet, and one of them is focused on this temporal analysis. I think that you will find it interesting.
Thank you.
You're welcome. More questions? No? Okay, that means that I was crystal clear. So I'm happy for that. Very quick, the exercise proposal. I will upload the exercises, okay? But basically, these are the assignments. This is just a proposal, okay, of things that you can do, okay? You will see all the instructions here, okay? But the idea is that you can do it in groups. Indeed, I prefer if you do it in groups, okay, of 3 or 4 people, to reduce the amount of work, okay? But if you can do it also alone and do some of the exercises, you know, with less things. There are some things, for example, these take into account that these sorry, after talking too much, these assignments are mainly focused to people that is from computer science, so that they are able to handle technology very quick or very fast, will be easy for them. For example, created a visualization of the data like we did. For some of you, if you are, for example, if you have been using, I don't know, D3 API or framework in JavaScript, will be really easy to go to the API of DisNet, retrieve some data, and do a visualization, okay? There are many options. Comparison of Wikipedia results versus PubMed or Mayo Clinic. Analysis of the results provided by the different Wikipedia snapshots. For example, Fiona, this is an analysis of the temporal evolution. Application of different similarity measures. There are many things, okay? Or you can propose me an exercise. Alejandro, I think that this can be interesting. You send me an email, I check it, and if I think that it fits, there is no problem with that. So, I mean, I give you several options, but of course I'm open for new options or for new exercises. Okay, I will upload this today at the end of the day, along with the slides and along with the video. Okay, everything will be uploaded. Remember to this URL that I will write in the chat, and you will have access. Okay, this is the short URL.
But do we have to do all the exercise, so we choose one? And
Only one. You choose one. You choose the one that you prefer, that you like more. And if you don't like any of them, but you have a proposal, you send me the proposal. And if it's okay, you can do your own proposal. I mean, I need to check that more or less match with the aim of the seminar and with the expected workload. But if it's okay, no problem. I mean, I give you facilities to do the work, okay? More questions? Yeah.
What is the deadline?
The deadline, it's in the slides, but I think it's 1 month from now. Yeah, March 12th, okay? I think that it's a reasonable deadline because I think that indeed, I remember that normally they ask us to give you less time, like 15 days or something like that, but I prefer to extend it a little bit more, so you have 1 month. Again, if you need a little bit more of time for some reason, we can extend. I'm flexible with this, okay? No problem. More questions? No?
And you will upload the video to this webpage too?
Yes, I will upload it. Yeah, I will upload it to YouTube and I will put the link in the webpage. Okay.
I don't know if I'm the only one, but the second link, the DisNet REST API examples, is not working for me. It's
okay, don't worry. I will check it and I will fix it.
Okay.
Maybe it's because I copy from the last year and I forgot to change the name or something like that. I will check it, don't worry. Okay, so if there are no more questions, thank you to all to being here. This at the end were 3 hours, okay? But I hope that you more or less enjoyed the seminar. If you have any doubt, any comment or anything, my email address, I will write you also in the chat, but I will include it in the slides, okay? You can write me and we will be happy to assist you, okay? Thank you very much.
Thank you.
Okay, thank
Thank
you.
you.
Yeah,
Bye.
thank you. Bye-bye.
Bye.
Bye.
Thank you. Bye.